Yet? Come on. I'm Jose. I'm going to talk about ZeroMQ and a bit of CakePHP. Actually, going to talk a lot more about ZeroMQ than connecting it to CakePHP because it's kind of trivial and not what you're interested in today. So for those who are here, congrats, you're very hardcore. This is going to be a very hardcore talk. It's going to be really, really exciting because ZeroMQ is extremely awesome. I don't know if any of you has background on network programming, like doing sockets and trying to do real communication between two servers, stuff like that. Anyone that studied computer science and yeah? No, but that's okay. But you try to do a network protocol or something like that, something advanced that you want two servers to communicate with each other, not through a HTTP server, but you wanted to do something advanced. So ZeroMQ is basically just an intelligent socket library for messaging. And it's incredibly flexible, and you can build your own patterns. A good thing is fast as hell. It was built by a guy that was employed by the stock market. So he built ZeroMQ to handle the real-time stock market flow. It's also fault tolerant. And one awesome thing about it is that it is language agnostic. So it's kind of a protocol where you can use a language, use its bindings, and communicate from one server to the other, from one process to the other, from one thread to the other in an agnostic way of communication. So what is not ZeroMQ? So it's not a message queue. So sorry to disappoint you. We're not talking about message queues today. We're not talking about the server that will load your jobs and keep them persistently in memory and try to balance them to the available workers. That's not what ZeroMQ is. Keep in mind that ZeroMQ is a library, not a server. ZeroMQ, as I already told you, is not persistent. If one of the nodes goes down and it has some internal memory, the memory will go away unless you add some logic to it to persist that memory, which is kind of easy. And again, sorry to let you down, it's not an out-of-the-box solution. If you're looking for a message queue, you can look into RabbitMQ, you can look into Gearman, whatever product you're into. This is, again, a library that will let you create network applications, concurrent applications, distributed applications a lot easier. So if you have done some network programming before, you'll know how hard it is to create a socket, to read the socket, to wait till the end of the socket and be fault tolerant. ZeroMQ makes all those things a lot easier. So why use ZeroMQ instead of X, being X, RabbitMQ, Gearman, etc.? And it's kind of the grand question to ask because ZeroMQ is like a paradigm change. It's not actually a server, it's something else. So you can hardly compare it to other solutions. To make things more clear to you, RabbitMQ has a connector to ZeroMQ. So RabbitMQ can work as a broker. We'll talk about brokers later. So if your system requires more advanced network interactions, some real-time interactions, or some real-time patterns, then ZeroMQ is for you. If you need real cheap and easy parallel processing, ZeroMQ is for you. If you don't want a single point of failure, like with RabbitMQ, which is a single broker, but you can kind of make it fault tolerant somehow, but with some kind of work, then ZeroMQ is for you. And if you need exceptional speed, then ZeroMQ is for you. And if you're quite cheap and don't want to invest in maintaining some servers, like for Gearman and stuff like that, then ZeroMQ is for you because it's very easy to do your own stuff with it. So let's talk about transports. Transports are the way how messages communicate or are transmitted from one server to the other, from one process to the other, from one thread to the other, etc. So the transports that ZeroMQ can use is in process, which is kind of cool. Obviously not for PHP because it's a single-threaded language, but if you have another language like C, Java, Python, Ruby, you can make those threads communicate to each other in a correct manner. So if you have ever done some parallel processing using threads, you probably know how hard it is. It's extremely hard to keep the critical zone safe. The critical zone is basically those variables that are shared that you don't want two threads accessing them at the same time because you run into race conditions. So if you use ZeroMQ to communicate two threads, then you solve the problem of the critical section. You can also use inter-process communication. For example, you have two PHP processes running on the background, and you want to communicate each other, hey, I did this. Did you do something else? Oh, yes, I did this. So you can communicate back and forth with other processes. You can obviously do that with things like a database, a caching system, but this thing is a lot more easier to use and a lot faster. You can also use multicast. If you want to broadcast a message to a lot of servers, to a lot of processes, then you can use multicast. Actually, it grabs multicast into another protocol, which is more stable. And of course, the good old TCP, which is the one that we'll use for most of our samples today. So let's talk about patterns. What can you build with ZeroMQ? And to be clear, patterns is basically what ZeroMQ is about. You can choose one of the patterns that ZeroMQ provides and combine them to create a single application or multiple applications talking to each other. And those patterns basically allow you to create advanced distributed systems. So this is the first pattern, and it's the most obvious, and probably you're super used to that because you are all web developers. You already know request reply. You can create a client which talks to a server, and the server responds back something to the client. So this is an example of creating a client in ZeroMQ using PHP. You basically create a new socket in a context of type request. Then you connect to your TCP port. You can just make that up. You can choose any port that is available. And the client sends has and waits for the server response. The server looks like this. It basically binds itself to the same address, and we have a infinite loop for waiting for messages, and while the server is receiving things, it just sends something back to the client. So we have built a communication servers with only 10 lines, and that is very cool. The good thing is that it's fault tolerant and it's extremely intelligent. If the messages have to hop through various nodes to reach the server, they will be stored temporarily until the machine is able to respond to your message. So your messages are rarely dropped, but if ZeroMQ detects that the server is not coping correctly with all the load, it'll start dropping automatically the messages for you. You don't have to code around those type of things. So this was way too simple, but there is a problem. A single PHP process won't cope a lot of multiple clients at once, right? Because PHP is single-threaded, right? It is. So what's our solution for this? Load balance all the things. And how do we load balance? So basically, in ZeroMQ, you start more servers. And you start more servers in different ports. And you bind all your clients to those different ports. And with ZeroMQ, you will automatically load balance the client requests to the servers for you. You don't have to create the load balancing logic. But it's a drawback. You need to hard code the addresses of the servers inside the clients, right? For example, if I have a client and I wanted to connect to 2 servers, I have to say, well, client connect to 555, 556, 557. If I have 100 servers, I need 100 lines. The good part is that is automatic. I mean, it will load balance for you, but it's a pain in the ass to maintain, because if you add one server, you won't change all the clients. So we'll be talking more on load balancing later to solve this particular problem. So the next pattern is publisher subscriber. This is one that is really, really cool. So you have a server that broadcasts things to the clients. So think, for example, on a notifications server. A user goes to your web page, it creates a new story, like a new commit if we're building GitHub. So the web server broadcasts, hey, Jose added a new commit. So you have a farm of other servers doing stuff. Oh, if someone does a commit, I should clear the cache. And there is another worker that says, oh, if Jose added a commit, I probably should send an email to the other developers. If Jose added a commit, so you have multiple servers doing different things at the same time with the publisher-subscriber pattern. This is the code for creating publishers. It's basically the same thing. It's always the same 10 lines. You just change the type of socket you're connecting to. So you connect to a socket of type publisher, and in this case it's special because I'm binding the publisher to 2 types of transports. One is TCP and the other is inter-process communication. So the publisher can publish its stories to multiple transports at once. You can do multicast, TCP, IPC at the same time. So basically, in this example, the publisher will forever get tweets from a system. It could be the stream API from Twitter that is new. It gets a tweet and publishes back to your farm of servers that will do something with the tweet. And the client, basically what it does is it connects to the TCP socket and it will listen. Notice subscriber set suck up subscribe filter. It will subscribe to all my tweets. So it's only interested in the tweets that are from Jose's app. And what it does is, well, basically nonsense. It will process the tweets. It could be storing in a database or calculating some metrics or whatever. So you can have multiple processes, for example, one process per each search that you do in Twitter and you want to process and do analytics on them. So publisher subscriber is like a radio broadcast. If you tune in later, you'll miss part of the show. And if the client crashes, it will also lose messages. It's also possible to attach multiple filters to the same connection. You can listen to tweets from Jose's app, you can listen to tweets from Dakota, you can anything. And the good thing is that you can also listen from multiple publishers at once. So if you think about it, this is super cool because doing network applications is really hard. So if you try to imagine doing that, probably using C, because PHP really sucks at networking, except when you use ZeroMQ. It's really hard to connect to multiple servers at once, do the polling for each socket, etc., etc., etc. So a real-life example of a publisher subscriber is Loggly. Has anyone used Loggly? Loggly is a cloud service for logging your database stuff. Like if you write into your log system with Apache, it will automatically send something to Loggly, and it will do some real-time processing and searching. So they use internally ZeroMQ to process all your log files, or basically everything you send to them, and stores them in whatever they want. I think they're using Elasticsearch. But all the internal processing and all internal broadcasting of the log lines are done with ZeroMQ. The other pattern is push-pull, using a sort of like a pipeline. You basically could have a client. The client talks to a worker. The worker tells the other worker to do some stuff. And so another example is using a fan, which is like a task generator. Send an email, deregister this user, do some stuff. So you have a list of workers that are available to do something, but only ones get the work. The one that's available, the worker sends to another farm of servers. There can be, for example, you receive an image. So you have one worker that trims the image. There is another that adds a watermark. There's another that adds a filter. And finally, there's a sync that validates that the image is correct and publishes it in your web application, and you have an Instagram or something like that. So this is our task ventilator. It basically just sends some workload to the workers. It's basically same thing, the same chain lines. You create a socket, you add the type of the socket, and for each time for 1 to 10 in this case, we just generate a random number and send it to the workers. And the push-pull is, and the task, which is our worker, basically just connects to the pull socket and do stuff based on that. And finally, our sync just connects to the final socket. If you see here, it has like one head and one tail. So the head receives work, it does the work, and the tail, which is another socket, another connection, sends back to another thing. So the workers never know if they're actually sending the result to another worker or actually to a sync. So finally, the last worker, which is the sync where all the workers converge, it just like sums it up. So the task generator was generating random numbers, the workers were adding something to it, and the sync is just summing them up, and it just echoes the total seconds. That's a simple process. Some things that you should know about push-pull is that it's one way only. So you cannot communicate back something to the task ventilator. Push is only used for fanning out tasks. You generate a task and you let the world know that something needs to be done. Pull is only used for fanning or sync processes where I get the results of what my workers did. Workers can hop in at any time. If you can detect somehow that your workers are not coping with the load, you just fire a few more workers and that should be it. And only one worker gets a task at the time because they are load balanced. So your task ventilator has nothing to do with the load balancing. It just sends tasks, and ZeroMQ will automatically detect which is the next one to get the task to be run. This is one of the extremely cool features of ZeroMQ. The task ventilator won't ever collapse. Or it could collapse, but it's really hard. It can still be sending and sending and sending tasks, but if it detects that no server can handle the task at that time because they're all busy with something else, it'll start buffering the task in somewhere else. We don't know where, it's the task of ZeroMQ, but it will start buffering the task, and when it detects that one worker is able to to work on it, it gets a task and sends it to the workers. So it's extremely intelligent because sometimes it does not buffer in the server, it buffers in the workers. So the workers get the state of the things that they need to do. So it really tries to make things as stable as possible. If a worker dies, well, that's a problem with the worker. The server must go on. It's really rock solid. But it will block at some point. If buffering is too high, then it will just block and tell you you need to do something about your workers. They're too slow. And this also is extremely cool.
Does it ever start swapping? Like with RabbitMQ, the old versions, if you filled up all system memory, it would just fall down. But they fixed that now.
Yeah. In the old versions of ZeroMQ, it did that too, because the high watermark was too high, or I think it was infinite. Yeah. But now you can set, I can just buffer up to 10 megabytes, 100 megabytes. And then
does it start dropping?
And it starts dropping, yeah. Or it depends on the protocol. If it's push-pull, it blocks, but if it's publisher-subscriber, it just drops messages.
Does it tell you it's dropping them?
I think you can do that, yeah. So I told you before that we need to load balance all the things. So this is where devices come in. Devices are basically brokers, are like middlemen that will route something from something. There are usually small programs that is just have the task of routing messages. Oh, you got all these messages from these clients, but I know that we have 1,000 servers. Let me route them to the correct server. So remember the old balance, all the things that we needed to define, like the list of all the servers the clients need to connect to, and that really sucked. Well, this is the new pattern. We have a lot of clients, they talk to a dealer or multiple dealers, and the dealer handles the servers and talks back. And if you think about it, this is extremely cool because ZeroMQ knows from, let me show you the example. This is a broker. It just basically adds a head and a tail, the front end and the back end. The front end will listen from clients. The back end talks to the servers, get the server back from the, get the response back from the servers, and responds to the client. What is extremely cool is that it's ZeroMQ who remembers from which client it came the request, from what server it came, and it connects the route for you. You don't have to maintain any state. It's just pulling a socket and responding back. You don't need to care about who's coming from where. So you just add a head, a tail, and you pull both backend and frontend sockets. So here in this loop, we get events. So what happened in the events? Well, I got from the client a message. Oh, so let me tell the server about it. But if it's a server that already has the response for me, let me tell the client. So we built a load balancer system in just 20 lines. And of course, if PHP is too slow for this task, which it might be for some things, you just swap to another language. You can do that in C or whatever language you feel comfortable with, Python if you like, because it's language agnostic. You just need to bind to the same socket and do the same logic. So devices, this is summing up what happened in this slide. The clients will connect all of them to the 9 port. The servers will all connect to the 60 port, and load balancing is done by ZeroMQ. Bad things happen. If the dealer breaks, then everything breaks. So we have now a single point of failure. But you can install failover dealers, which connect. So you can make your application and your patterns as much complicated as you want, and with as much failover as you want. So it's up to you to decide how good your application is. The devices definitely allow you to create topologies that are complex. It helps you to route requests to anonymous workers, as this is the place for creating or persisting the messages. So if you want to persist jobs somehow, you can, for example, use Redis or whatever other database and store the workers there. So if you lose for some reason a work, you can give it that, bring it back to memory. And you can, of course, write the brokers or the workers or whatever in any language that is supported by ZeroMQ. So finally, let's see some quick examples. So you have two very, very simple examples. Well, actually, one is not that simple. So we have a couple examples here. I have a client-server thing. This is just, let me show you the code. This is the client. It connects with a request socket. It sends 5,000 requests to the server. And the server is just something that gets a response and sends response with world. Okay? So the client says hello, and the server responds world, and the client finally echoes the result. So let's see how that works when you have multiple things going on. So you have a server. The server is now listening for requests from the client. And now the client is sending requests. You can see how far it is. Okay. So basically, it just receives hello, and the client says world. One cool thing about ZeroMQ is that the client can connect at any time, then the server hops in and it starts working. So extremely cool. And okay, let's see another example. That's request reply. Let's see something about push pull. We have the ventilator. It's basically creating some random numbers that will be sent to the workers. Our workers will be just reading the string or the number, multiplying by 1,000, and send it back to sync. The sync will just sum all the random numbers that we received in our workers. So let me fire another console. So let's see what happens. I have a task ventilator. Let me fire up some workers. PHP task. This is another worker. Sorry. So let me fire also the sync, and finally the ventilator. So the ventilator asks me, are all the workers ready? Yes. Let's see how that works. So it's automatically load balancing my tasks. It sends half the request or half the works to one worker and half the other works to this other worker, and this one summed up all the seconds that were sent from the task ventilator. A cool thing is that, let me fire another one. Those workers are still live. I will start the ventilator. Let me get this ready for action. All my workers are working now, but I start this now. It was too slow. But if the workers cannot cope with the load of the server, then the third worker will start immediately getting information. So as the workers were too fast for responding with this task, this one did nothing. But if I send again, most probably it will load balance on the 3 of them. There you go. So this is extremely cool because you can also do things like this. You start your, this one is PHP server. This is the sink. So the server is there, it's doing stuff, it's trying to send works or jobs to the workers, but there are no workers available. But as soon as a worker hops in, it should start receiving. If it doesn't work, it's because I did something stupid. Okay, I don't know what happened. Sorry? Oh yeah, it's a ventilator, sorry. So my ventilator is there. I tell him that there is task for the workers, but it blocked because it sent too much and it detected, okay, no one's doing nothing. So as soon as a worker hops in, it starts getting tasks. Okay? So finally, the last example I want to show you, this is actually real cool and one that took me a lot of time. There is a guide on the ZeroMQ site, which is super long but super interesting, telling you how to create distributed network applications. And there is this single example of doing something really cool that I will explain to you that was not translated to PHP. So I took the time to do it. So this is a real-life use case that we needed to implement. We have all these servers. We have 15 servers, and they all have all the applications of CakePHP. But at some point, we need to change the version of something in every application. So we need to somehow tell all the servers, oh, we need now to change this file. But the problem is that if one of the servers goes down while the message is broadcasting or something happens, it's down for 30 minutes, it misses a lot of things because it will hop in and will have a very old version of that file. So it needs to somehow know that it's behind everyone else. So I built this based on the code that you can find in the ZeroMQ guide. So basically we have a storage object. Oh, this is Python. We have a storage object which is just a dictionary. It gets the latest version. And we have a state manager, which basically is a router, is a device or a broker. It pulls the sockets that it has available. But the cool thing is that it also connects to a pipe, to another process in the same machine. So I'm faking threads in PHP, and that's really cool. So what it basically does is the server, it forks itself and starts the state manager. The state manager is the one single thread that says, well, the latest version is 5, the latest version is 500. So that single thread will listen for the servers that are behind and tell them, hey, the last version is this one. You missed all those changes. So basically, I don't know if you get the idea, it's cloning the state of all servers real time. Do you get what I mean? Probably it's a very, very complicated example, but it's really cool. What it's doing is there is a server publishing new versions, and all the servers need to be at the same version at the same time. If a server goes down, as soon as it pops in, it needs to get all the updates from the other server. If there are 2,000 updates, they need to run them all. Okay? And it needs to do that real time. So let's see how that works. Okay, so I have a lot of, this is simulating all the servers. Let me start one, PHP. This is a client. The client is started is basically emulating one server in our cloud, and it starts the main server that pushes the updates. So it started getting updates like crazy. So it started another server that was down. And if I stop it, you'll see that it received the latest snapshot, which is this one. And it started getting from the next snapshot. And if I start a new server that was actually down, or I hop in another server into the cloud, it'll start getting, the latest one, and it starts again. So it doesn't miss any single update that the server is publishing. And one of the cool things of this is, in my opinion, the fork that is emulating threads in PHP. No one had translated this example to PHP in the ZeroMQ guide because PHP didn't have any threads, but you can emulate them with ZeroMQ using sockets. So I think that's everything for now. If you have questions, if the talk was too thick, I understand. But I'm glad you were here, and thank you. Do you have any questions? Yeah, there is. I don't know if you're familiar with the training, CakePHP training. The training.cakephp.org is using ZeroMQ. And it's kind of cool because it uses the multiple languages to do a lot of stuff. What training.cakephp.org does is you create a new course and you set up a reminder with a Node application that we have, which has a timeout, and it's connecting to a ZeroMQ socket too. So at the time that the server needs to boost up, because there's going to be a class in 1 hour, the server reminds using ZeroMQ, and it starts the server in Amazon. And when the server in Amazon is up, it notifies something else. But basically what it does, we emulated a message queue with PHP, for CakePHP, in this plugin, ZeroMQ. What it basically does is, actually it needs some updates, but it used the login system. Now you can use the event manager. What it does is gets a connection, published using its push socket, marshals the message. It's just type of work, and this is the data that you're sending, and you write to the socket, and that's it. And with what we have available is a Node server, Node.js, that listens to that socket using ZeroMQ library and starts cake shells, basically. It's just up, it gets messages from ZeroMQ and dispatches cake shells. So we did that with Node.js because we wanted something that was light and was forever running and could listen to any kind of works at the same time. So I think this plugin is not available, but I'll make sure it's available before Sunday. Okay? Right now it's like a log engine. It doesn't make much sense. That's what was available in Cake 2.1, but we now can use the event manager. So I'll make the updates. Another question? Okay, thank you.